Okay, so we're going to continue looking at computer organization, and now we're going to look at application software. What we'll see here is the application software sits on top of the operating system and is essentially what the user sees. There's lots of different types of application software. Essentially, these are programmed for the end user, to enable them to do very specific tasks. There's lots of examples out there. You just need to turn your computer on, you'll see examples. Word processors, spreadsheets, web browsers, email, graphic processing, presentations like this one. There will also be maybe utilities as well, which maybe are closer to the operating system but are really applications that sit directly on the operating system. Like, for example, the Windows Explorer or the Finder in Apple. That little application that allows you to actually look at your files and see where your files are. Because essentially, that's what the user wants. They create and they modify files, be it a letter in your word processor, account, say for example in your spreadsheets, or a page from Wikipedia on your web browser. So that's your applications, and you need to be very comfortable with the types of applications that we could possibly be talking about. Common features of applications. These days most software has a graphical user interface or a GUI, and we'll look into that in a little bit more detail in a moment. But if we went back in time, then everything would have been a command line interface. Basically what that means is you need to remember the commands to enter, and you enter those commands, you type them in using your keyboard from a terminal similar to what is down here in the image, and you enter that command would be run. There might be some extra components you might give to it. So for example, there's a list of commands up here which we could be running, and so PS is the command, and the alternative begins with AUX, and then there's a bar here that's known as a pipe, and then we can actually come to another command here, grep, and then a question mark. So those are the commands, and possibly some arguments or extra information that goes into the command to say exactly what we want to do. ifconfig -a, uname -a, sudo apt-get update, and sudo apt-get upgrade. All of these are different commands from the command line interface. Now, from a programmer's point of view, command line interfaces are much easier to program, because we say, here's a command, I'm going to get that in, the user will enter, I'll read the command, and then I will execute that command. From a user's point of view, they're a lot harder, because you've got to remember the commands. You've got to come up, what was the switch or the extra little bit of information I wanted to add to the command? Did I remember the command correctly? So a graphical user interface is much easier for the user. And really the time when computers started to take off was when graphical user interfaces became commonplace. So that's the last little thing we want to have a look at today. Features of graphical user interface. This is a pretty old screenshot of a Apple machine, but it includes all of the classic features that we talk about. There's this acronym called WIMP, which stands for Windows, icons, menus, pointers. The Windows, that does not mean the Windows operating system. That means we have dialog boxes, we have windows where information appears in. Icons, these are the sort of things as we've got here, which shows us, in this case it's showing you about the system and where you've got some files hanging around. On the desktop down on the side, there's different disks that are attached to the system, and in the Mac tradition there's the trash can as well. There are menus, so that means that's the way the user can enter the commands, but they don't need to have to remember the commands. They can say, well, it's something I want to do with the file, I think. They go to the file and a list of possible commands come up for them. If they need to add extra information, maybe a dialog box, another window will appear to allow them to enter that pieces of information. So they are still doing the same, but there's extra code that needs to go on top of this. And of course, how they select this is with the pointer, the cursor. They move that around and they point to things and say, that is what I want. Now, because these elements are so common these days, this tends to be an element within our operating system. So the operating system itself will often produce that sort of desktop layer. It will provide the methods that the programmer can use to access ways to draw windows, to attach menus, to respond to various controls that the user may be using, like a menu, or maybe we've got a dialog box, and inside that dialog box there are different controls, such as a edit box, or a slider, a radio button, a push button. All of these different controls would be defined by the operating system. And so then the application programmer says, okay, I'm writing for this operating system, it has these particular controls, I will use their methods. So it makes their work a lot easier. They're building on top of something that has already been tested. So that's basically the idea behind application software, and how application software and operating systems sort of share the load. You don't have to write a program to actually write little bits onto a file, on say the hard disk. The operating system will manage that for you, but you will need to sort of call those operating system methods.